Now we can start another chapter that is called randomized algorithms. Okay. We are, as I'll be teaching this randomized algorithms, then another chapter that the graph algorithms I'll be teaching. Okay. Graph algorithms. Then I'll be teaching these approximation algorithms. Okay. Approximation algorithms. Then I'll be teaching, say, perhaps this NP completeness. Okay. So these are the chapters that I'll be covering, and this greedy and dynamic programming will be covered by Shubham myself, right? Okay. Let me go through the introduction today, and then from the next class onwards we'll be going in detail. Okay, as well. So this randomized algorithm, I'll be discussing these three problems. That is hiring assistant problem, and then this randomized quick sort, and then this randomized min card. Okay. So first, this hiring assistant problem we can discuss, and the main source of this discussion is this CLRS for this hiring assistant problem. Then randomized quick sort for this CLRS, and then randomized min card from this Midzen, Matcher and Uffal. Okay, this book, Probability and Computation. Okay, so let us start with an example, this hiring assistant problem, and how this randomization can help in designing algorithm. Randomization is so pervasive in algorithm design. Okay, the more you will be going through the randomized algorithms. I offer a separate course in MTech for randomized algorithm. Okay, this randomized algorithm is everywhere, right? Many a time in algorithm design process, we apply this randomized algorithm. So we are starting with one example, and that is, say, Google will conduct one campus interview. Okay, Google is conducting one campus interview, and they have asked a list of students from the institute authority. In your case, it is previously it was TPSW, and now it is CDC. That will be looking after your campus interview process and others, okay, related to that. So they are planning to come to the campus interview, but what they are doing means they are wanting to conduct one campus interview, but they are not coming physically on the campus. They are asking CDC to provide a list of students, okay, and from that list, each day they will interview one student. Okay, each day they will be interviewing one student. And their policy is if the current student being interviewed is better than the previous. So this guy, Google is interviewing, he is smiling. Okay, that guy is smiling because the Google policy is that, okay, this is the first candidate. So Google will not be able to compare this guy with the other because this is the first candidate. So that guy will be hired. But hello. হুম না আমি এখন ক্লাসে রয়েছি একটু পরে এসো হ্যাঁ so their policy is that, okay, if the current student being interviewed is better than the previous, they will hire this candidate and will fire the previous. So the next guy is coming. And then next guy is say performing better than this guy. Then this guy will be fired. Okay, this guy will be fired, right? Will be little bit depressed, right? And then this guy will be hired, right? With a big smiling face. Okay. So this is the Google's policy right now for interviewing, hiring, and firing. But uh, if somebody is working for, say, instead of day by day, you can think of 1 month after they will be interviewing the candidates, and 1 month you are having a job in Google. Okay, then that will be strengthening your CV, right? So in that way, you are benefited. So, but this hiring and firing process will be going on. Okay. So this way the interview process will be going on, right? And now the thing is that after interviewing n number of candidates, they will settle for one student, that is one assistant, and this is why it is called hiring assistant problem. So ultimately, this hiring and firing process will be going on, and after n number of candidates are exhausted, then they will be settling for one assistant. Okay, and that guy will be permanent. So this is the problem, right? But this problem is might be fooling Google. Okay, if Google is not paying some kind of attention. Okay, so the thing is that Google will interview according to the list provided by the institute. Okay, according to the list provided by the institute. Say the institute provide the list based on CGPA, and more is the CGPA, better is the candidate. Okay, so that you know, if somebody having 60% CGPA, okay, and somebody having 90%, so 90% guy is better, right? And the institute is sensing, say maybe I have been one of the advisor in that CDC, and I am wanting that every student at least should be having 1 month experience in Google. Okay, then by seeing that I am sensing that Google will be trusting my list, and then what I am doing is I am giving the list to the Google like this way. The CGPA wise, 60 guy will be given in the first, 65 next, 70, 75, 80. Okay. So if Google is trusting me, then the thing is that Google will be trying to minimize as less number of candidates to be hired as possible. Okay, that is also their objective. Okay, but if they are trusting my list, okay, then that objective will not be fulfilled. Okay, that objective will not be fulfilled by the Google. So the Google at that time will be forced to hire all in candidates at least once. Okay. So this is the way we can fool the Google. But the Google is having lots of brain. Okay. Right. So they will not be trusting. Right. So always this guy who is there in Google, they will be wondering means some fishy list might be provided by the institute authority. Okay. Then what Google will be doing? So at this point, the randomized algorithm is coming into picture. Randomization is coming into picture. Okay. This guy will be telling, okay, after thinking a little bit, this guy will be telling to the Google that, okay, we can randomize the list, right? So then if I am randomizing this list, maybe this list, okay, this example is there, okay. So Google is randomizing the order of the interview. So this, after randomizing, the Google is getting this. So this 70 is coming first, then 60, then 65, then 80, 75. Now if Google is starting to interview, then what will happen? The 70 guy will be hired. Okay. Then 60 guy will be coming. And as you know, the general perception is that the guy who is having 60% CGPA, whenever we are giving huge amount of marks, still he or she is getting 60%. So that guy might not be performing that much better. This is not a generalized case, but this is something intuitive. Okay. So that means, so with that intuition, if I am going, then this 60 guy will not be performing well, better than this 70. So 70 guy will be retaining its position. 60 will not be hired. 65 also will be having the same thing. Then 80 guy is coming. So 80 guy at that time, this 70, okay. This 70 guy, okay, this will be having real disappointment. Okay, so this guy will be out. And then this 80 will be in. Okay, right. And then this 75 guy will be coming, but his CGPA, his or her CGPA is less. So he'll also not be hired. So in this process, we are hiring two candidates. Two candidates. That means Google hiring two candidates instead of all five candidates. Okay. Now the thing is that there will be a theory. There will be one theorem or lemma that is telling that if we are having n number of candidates and if we randomize the list, then Google will be having huge benefit because they will be able to hire only log n number of candidates. So if Google is if n equal to 2 power 64, so Google will be able to hire around these 64 candidates. That's okay for Google. Okay, right. So this is the hiring assistant problem, and this n number of candidates are there in the interview process, and ultimately this order of log n number of candidates will be hired. That will be ensured by the Google, but how? Because of randomization. Okay, so this is one of the very good examples of how randomization can help designing algorithms. Okay, so we'll be proving this fact from the next class onwards. For that, we need some kind of probability, basic probability. We'll be having a recap on that, and then we'll be proceeding to prove this bound. Okay. Okay. So, any question?